geothermal is basically heat from the earth. Resources range from the shallow ground to hot water and rock formed found in just a few miles beneath the Earth's surface, and even deeper to the extremely high temps of magma. We need geothermal because, number one, we're running out of fuel, and it is also a green energy.
Hello, Middle States. This graph demonstrates what geothermal's importance is. What we have here is the annual cost comparison. This is your typical 16-SEER HVAC unit, which most standard houses have. As you can see, those are like pretty high, which indicates pretty high cost. That's your geothermal system. Very cost effective. What we're going to do today is we want to take you on a little journey through geothermal and the technology and the energy by first describing how it works. Then we want to move on to kind of benefits, the pros and cons of these systems, why you want to put them in there. And then we want to bring you to what the future of geothermal is. Which brings us to the topic of our okay, well, what geothermal is, it's exciting, it's the future, and it's exciting. And without delay, we're going to move on to how it works.
Okay, so now we're going to talk about the type of geothermal energy, the differences in construction of geothermal energy heat pumps, and also I will tell you what will it take for you to install it in your yard. But first, we will watch the short video that will lead you through the different types of geothermal energy.
Radioactive decay of minerals. There are several methods for harnessing this energy. Geothermal energy is generated and held in the Earth's crust. The deeper into the Earth you go, the hotter the temperature of the rock. In non-volcanic regions, the temperature generally rises 2 to 3 degrees Celsius every 100 meters, the heat deriving mainly from the natural radioactive decay of minerals. There are several methods for harnessing this energy. Very low temperature geothermal energy can be captured at relatively shallow depths of up to 100 meters, where the temperature of the rock is generally below 30 degrees, adequate for heating individual homes with the aid of a heat pumping system. Low temperature geothermal energy is drawn from deeper into the Earth, where temperatures rise from 30 to up to 150 degrees. Rainwater, which permeates the ground and is warmed by contact with porous rock, is extracted through drilling and can require a replenishment of the water table. This form of energy is generally used for collective urban heating systems or for heating large buildings. High-temperature geothermal energy can be harnessed from deep resources 1,500 meters beneath the surface, where temperatures rise above 150 degrees, allowing the production of electricity. Geothermal energy is considered effective, reliable, sustainable, and environmentally friendly, but by extracting heat from the Earth, the rock cools down, causing depletion of resources. If production is reduced, a geothermal deposit will replenish itself, though it may take decades or even hundreds of years to do so.
Alright, so the differences in composition of soil and ground and the availability of ground and surface waters really impact the design of the virtual heat turbine that you're going to be using. And there are three main types of heat pumps. The first one is a dry steam pump. It's the most simple one. Basically, you dig a hole in the ground, and the pump will suck the vapor out of the ground and use it. And after that, the water will condense and will be reused again. For the more complicated areas and where we can get the water temperature higher than 350 degrees Fahrenheit, the flash steam heat turbine will be installed, and it will be using the high pressure. It will be getting the water out of the ground, and due to the difference in pressure near the water surface, the steam, the high temperature steam will be generated, which will move the turbine, and the water will be used again. And the third type is binary cycle type. This is the most complicated one, and it combines the properties of both types that I mentioned before. After you determine the design of the geothermal heat pump that you're going to be using, you need to figure out the way you're going to finance the conversion to green energy. It will cost you about $26,000, no big deal, but don't freak out. United States luckily offer big tax benefits, around 30%, and due to other benefits that the next speaker will cover, the heat will really go, the cost of the installation will really go down. Dan?
Okay, pardon me, it's all the yelling and screaming. We've come to realize that geothermal is an excellent source that is cheap and reliable, and a simple economic way to clean and filtrate our earth and everything that envelops our earth. That being said, its significant cost of savings is the cheapest source of power that generates. It also reduces reliance on fossil fuels. It does not create pollution. The direct use makes geothermal energy cheaper and affordable, and it also creates jobs. On February 13th of 2009, President Barack Obama introduced a proposal to cut pollution, to allow states a separate pollution reduction target. The cap and trade programs were correlated in compliance with the Clean Air Act. The proposed stimulus bill received 60 votes, the minimum needed to pass. In retrospect, the stimulus bill also created and saved 3 million to up to 4 million jobs. Republican and some Democrat conservatives were adamantly opposed to the size and content of the bill. In 2009, part of the American Recovery Act, the United States federal government has approved a 30% tax credit for homeowners installing a qualified geothermal system. Unlike prior legislation, there is no maximum credit amount. And the state of, according to energy.com, in the state of New Jersey in 2007, 160 households installed the geothermal system, which cost which covered 160 households and costing $216,000, with a combined refund of $150 per household and $100 per contractor. And now we're going to focus on the future goals.
As we all know, gas is dominating the fuel market, and we are highly dependent on foreign countries for energy sources. However, the rising popularity of geothermal energy will decrease dependency on energy sources, plus lower the prices for residents to get geothermal heat pumps. It will also open up more businesses, which will eventually create more job opportunities for workforce. Lastly, frontiers are what we explore. As we move forward, geothermal technology will be part of our future, a future where our children will have clean, sustainable, and renewable energy. Thank you.
As our hypothetical action, we decided that we would like to try to create a proposal to get the campus community and even county involved in building an eco-friendly Habitat for Humanity home.
And last but not least, a great shout out to our advisor, Ted. Thank you. And any questions?
One.
One.
Right here.
You.
Difference between, okay, I want to know, how much side space is there between closed and open loop systems, price difference, and how much space would it be private?
I'm sorry, can you please repeat the question?
The price difference between a closed and open loop system, would it be even viable if you're using a closed loop system in like a suburban area where you need some more space with a closed loop system? Okay, because with an open loop system, you're going to create waste because you're going to be always working for one person.
Break it down.
Well, the price difference isn't really that much between the last two types, which are more complicated. Well, the first one, of course, is the most cheap one, the dry heat, basically 700 vapor. Well, 5,000, and the two other types will cost around 26,000, but the tax credit and everything will make it cost about $18,000. This is data from New Jersey.